Hello everyone, welcome to Machine Learning with Python package TensorFlow Part 2. So go to your Anaconda Navigator and let's create another Jupyter Notebook. Just give it a second. So I need to find my Jupyter Notebooks. It's for me, and for you guys, I need a new one. So today we're going to work on image classification. And you can come to tensorflow.org/tutorials/keras/classification. And basically, we're given 70,000 images of a bag, sneaker, shirts, ankle boots, and we're going to make a machine learning model that can actively predict what an image is. Like, is it a shirt, sneaker, book, boot? And so we're going to start building that. Together. Alright, so first we're going to import the packages. So we gotta say import tensorflow as tf, say import numpy as np, say import matplotlib.pyplot as plt, and I'm going to say from tensorflow import keras. Shift enter. So TensorFlow is the Python package that allow us to create our machine learning model. NumPy is a numeric processor. It's how we'll create arrays. TensorFlow only works with arrays. Matplotlib.pyplot is just like a way to use Python to create graphs. And keras is just a special function in TensorFlow. So this image sample comes pre-installed with TensorFlow, so we're going to create it. So we're going to call it fashion_minst is equal to keras.datasets.fashion_minst. So this object, that name doesn't matter, but this matters. The equals keras.datasets.fashion_minst. So now we need to create the training images, the train labels, the test image, and the test labels. So train_images, train_labels, parentheses test_images, test_labels, parentheses, then equals the object we created, fashion_minst dot load_data, parentheses. And you notice in the first line of code I said fashion with an O, but the object itself does not contain an O. I think I did it here again. Yeah, that's the error I was trying to warn you about. So basically what we did is we took the 70,000 images and stored it in an object called fashion_minst, and then I created objects called the train images, the train labels, the test images, and the test labels equal to the data that is in that object now. And so basically when you create a model, when you have limited data, even though it's 70,000 images, you need to split the data into your training and testing. It's good to use the majority of it for training, but you need the testing image to test the model for stuff it's never seen before, because that's how you can tell how accurate the model is. And so that's what we did. And so now, if you want to see what this looks like, you can do plot.figure, parentheses, and then plt dot image im show parentheses train image brackets 0. So this is going to display the first image, plot.color, color bar, plot.grid false, and then plot.show. So we created an object with certain stuff. It's not that important. And then shift enter, and it shows us the picture of the first image. And basically, you see where the dark pixels are, that's nothing. But the brighter it is, the computer knows that's where something is. And we have the pixels values in a range of 0 to 250. I think 255. And that's for purposes of training the model. And to see how big the training model is, you can do train image dot shape. And that'll show you, so 60,000 images by 28 by 28 pixels. Or you could just do length of the train underscore labels. And so there's 60,000. And then, you know, some extra stuff like the test image, length of test labels, all the same thing. So for purposes of this lesson, it's a good idea to scale these values in a range from 0 to 1 before we feed them into the neural network model. So to do that, we say train underscore images is equal to train underscore images divided by 250.0. So we do 250.0 because that'll make it a double, which is more accurate. And so what we did here is we said, I have this object train images, set it equal to itself divided by 255.0, but reassign it to that value. So that's what it did. It reassigned itself a new value from an existing value. So that's kind of cool. And do the same thing for the testing images. Just enter. So yeah. So now we're going to do the same thing as the last tutorial. We're going to create an object called model, and we're going to set it equal to keras.sequential parentheses and brackets. However, we have three things we need to put in these brackets. We have the keras.layers.flatten parentheses input underscore shape equal to parentheses 28 by 28, and then comma keras dot layers dot dense capital D parentheses 128 by activation space comma activation equal to ReLU. See if I can put this on a different line, comma, and then now I'm going to say keras.layers.dense is 10. So I believe that's all I need to do. Shift enter. Alright, so what do we do? So the images are 28 by 28 pixels. However, you have to understand that that's stored as data in an array. So the flatten just tells the machine, create an image, a 28 by 28 image from the data set in the array. So it doesn't look like this in the data, it's just like numbers. So we're telling it create the image. That actually has no effect on the data itself. But then we create layers.dense 128. So 128 means I want you to create 128 functions and assign values and parameters to each function to create the model more accurate. And activation equal ReLU, that's just I forget what that is. It's basically like another parameter to make it more accurate. I believe that is ReLU is I don't even remember. And then we say keras.layers.dense10 because we want the machine to predict on a scale. We have 10 options that the model can predict: a shoe, a boot, and a shirt. And then, yeah, so that's what we did. So now we need to compile it. So we say model.compile, and we're going to set the optimizer equal to Atom, comma, and the loss equal to tf.keras.losses.sparse categorical crossin trophy parentheses from logits from front underscore logits equals true. And then I need a parentheses metrics equals brackets quotes accuracy. Shift enter. See if that works. It did. So optimizer Atom, that's just a parameter, but the sparse categorical Crossan trophy, you're going to want to be careful creating that. And then metrics accuracy, that'll just display the accuracy for the model. So the sparse categorical Crossan trophy is basically, I believe, an algorithm that determines like how dark a pixel is and how light it is, and compares, is that an actual image? And then we're going to say model.fit parentheses train underscore images comma train underscore labels epochs equal 10. Shift enter. So I said take the training images and the test labels, the train labels, and learn 10 times. So basically it's going to look at all those 60,000 images and try and find relations. Alright, the loss seems pretty low. And then now we're going to see, we want the machine to print out the loss and the accuracy and see how it compares to the test accuracy. So I'm going to say test underscore loss comma test underscore accuracy is equal to model.evaluate parentheses test underscore images comma test underscore labels comma verbose equal to 2. Enter. So basically I said I created a variable that sets it equal to kind of like this. It kind of trained with the test images this time and showed you the accuracy of the model when it was given new values. So accuracy 87.95, and this should actually be, oh, I forgot a line. So print parentheses test accuracy comma test accuracy. So you can see the accuracy, I guess it's not shown very well here, but the test accuracy from the test is different, is lower than the model when it has the training images. So you can see the loss is slightly higher, so that's bad than this. And that's this thing called overfitting, but we'll learn about that a little bit later. And so now we can use this to predict models. So we're going to create a function that will do that. So probability underscore model is equal to tf dot keras dot sequential parentheses brackets model comma tf dot keras dot layers dot softmax parentheses. So we've created a function that will be able to give us we've created one part of a function that will be able to predict. So next is we create another variable called predictions. And set it equal to probability model dot predict parentheses test underscore images. Probability There we go. So now we can pass in any object we want in brackets, and it'll give us what it thinks it is. So we're going to try prediction 0. So we're going to use the first image in the data set. And remember, that was this train image here, which is an ankle boot. And you can see in the category, an ankle boot is 9. So we're hoping to get a label of 9. So we're going to say Shift Enter. I did it again. And you can see it gave us all the values in very weird numbers of what it thinks it is. However, we can say numpy dot argmax parentheses predictions brackets 0, and it'll give us 9. And we can say test underscore labels brackets 0. So it did it. It worked. So that's how we created an image classification with 10 categories and 60,000 or 70,000 images. So it's, again, similar principle. We ready the data. We say model equal to keras.sequential, compile, fit, and then it took a few more steps to create a function to predict, but the general principle is still the same. And we actually were able to split the data this time. And just the really only differences is the loss, the optimizer. So those all depend on the situation. But yeah, thank you for joining me.